Hi, how you doing, ladies and gentlemen? It's Mr. Pouts, and this is a video for section 3.2, dealing with our inequalities again, but this one is entitled Solving Inequalities Using Addition or Subtraction. So it's just like solving equations, only we're going to be solving inequalities using addition or subtraction. So why don't you write this goal down on your goal sheet? So start by doing that and thinking about how we could be solving inequalities using addition or subtraction like we did with equations. So, our one term for today is equivalent inequalities. So I'd suggest writing that down. It is one of your key vocabulary terms for the chapter. Just like equivalent equations, equivalent inequalities are inequalities that have the same solutions. All right, we talked about finding solutions or identifying solutions in section 1. So we're going to be dealing with equivalent inequalities today. So the first thing that we're going to talk about is the addition property of equality. How we can use inequality. How you can use addition to solve an inequality. So I have it in words and in a picture here. The words, basically it says if you add something to both sides of the equation, remember what you do to, of an inequality, what you do to one side of the inequality you must do to the other, just like equations. But if you add something to both sides of an inequality, the result will still be an equivalent inequality, having the same solutions. So here's a diagram over here. If you're starting with b being less than a, and you add c, or whatever number c would be to both of them, even if c was 6. If you add 6 to both b and a, well, b plus 6, or b plus c, is still going to be less than a plus 6, or a plus c. All right? So showing that it'll keep it equivalent. So let's do some examples that you'll see together in your practice of this. But just another little tip here, it's just like solving a one-step equation using addition. So here we have x minus 15 is greater than negative 12, but it says what are the solutions to that inequality, and graph them. So I'm going to make a graph here. But I'm going to show you up over to the top right here how it would look as an equation. X minus 15 equals negative 12. Now we know to solve that, as if it was an equation, we would do the inverse operation, which is addition, adding 15 to both sides of the equation to get the x by itself. And negative 12 plus 15 is positive 3. So solving this inequality is the same exact thing. We're using the addition property of inequality. We're adding 15 to both sides because that will be the inverse of the subtracting. So the x is all by itself, and we have 3 over there. 15, sorry. So your inequality that when you solve for it is x is greater than 3. So you got to take your graph, and the times you have to make your own graph. 0, you don't have to include every number, but just make sure the number that you're dealing with is included on the graph for sure. So I'm going to take my 3, and remember, since it's just greater than, and not greater than or equal to, since it's just greater than, we use an open circle. We use an open circle at 3. Anything greater than 3 would be going to the right. So that's how I graph that inequality. So I want to have you do the same thing with the second one. Try to solve this one on your own and graph it. So you have n minus 5 is less than negative 3. Your addition property of inequality would be to add 5, because negative 5, or minus 5 and positive 5 cancel each other out. Or if you change it to plus and negative 5, adding 5 would still make that go away, make it 0. So you then add 5 to the right side, because what you do to one side, you must do to the other. And negative 3 plus 5 is positive 2. So our final inequality, which would be an equivalent inequality to the start, would be n is less than 2. So I'm going to make my 0, 1, 2, 3. That's enough here. So it's going to be an open circle again. Open circle at 2, and if it's less than 2, it has to go towards the left. Anything less than 2 would be in that direction. Alright, so here's, I have two more examples, and I just want you to, there's one thing that I have different in the directions. You have an inequality, but it says graph and check. So I'll show you how to check the solutions, kind of like we did in section 1. So let's take a look at, and let's solve it first, and we'll graph it and we'll check it. So, we take our, let's take our 10 is greater than or equal to 3 minus x, or sorry, x minus 3. Alright, the one step to solve for x would be our addition here, addition property of equality, adding 3 to both sides. Oh, whoops. Make sure you add it to the other side. You have to do it to both sides, just like an equation. X is left over there, you solve that, and you have 13. Now, I've told you this before when we were graphing last section, that you should, before you graph it, like we want to graph it here, but before you do that, you should switch it around, so that the variable is in front. So if you put the variable in front here, you put the number in the back, and you have to then flip the sign. So if it's opening up to the 13, it still should open up to the 13, but that would mean it's turned into a less than or equal to sign. And so when I graph that, I gotta make sure 13 is on here. This will be going up this way. 0 is over this way, so we'll go 12 and 11. The graph would be a closed circle this time because it's less than or equal to, and it's at 13. A closed circle at 13. And since it's less than or equal to, it's going to be going backwards, back towards where the negatives would be, back towards 0. So that's the graph. Now the checking part, what I'm saying about checking, if this is our original inequality, and this is what we're saying is now the restrictions has to be less than or equal to 13, we want to check to see, like, what if we plug in 13? It should be equal then. And we can also plug in one that's left and less, and it should work out then. So we plug in 12, we'll do 13, we'll do one less, whoops, we'll do 12. So when we plug it into our original, we have 10 is greater than or equal to, we'll put 13 in right there. And we'll do the same thing. Well, we'll just finish solving this then. So that's 10 is greater than or equal to 13 minus 3 is 10, so it is equal. That means that is correct. Now let's check the less than part. So we're going to use 12. And when we plug in, we have 10 is greater than or equal to, we're going to plug in, oops, that's a 3. We're going to put that 12 in there. Now, 12 minus 3, if I simplify that side, we have 10 is greater than or equal to, that's 9. So that is greater than 9, so that is true as well. That means by checking it there, we just showed that, yes, x's that are greater than or sorry, less than or equal to 13 are solutions to this inequality. Then you can check the graph. It should be either 13 or less. So let's do one more like that. I'd like you to solve it on your own first, and then we'll graph it and check it. So we have m minus 11 is greater than or equal to negative 2. To solve that, we do our addition property of inequality because sorry, not 2, we're going to be adding 11 because that'll cancel out the minus 11 that's over here. Add 11. That'll cancel out there. You have m by itself greater than or equal to negative 2 plus 11 is 9. If I graph that, got to have 9 on there. So it'd be going up 9, 10, 11, 12. This way it'd be 8. I know this is a really sloppy looking. I'd suggest making it a little bit cleaner looking, but as long as you have the numbers in the correct order, it's going to be a closed circle because it's greater than or equal to, and it's going to be going greater that way. So what I'm going to do to check, since we said it has to be, the numbers have to be greater than or equal to 9. We're going to use 9, and we're also going to use something greater than that, which is 10. So let's plug it in. Let's do 9 minus 11 is greater than or equal to negative 2. Hopefully it's equal to, and then we'll do 10 minus 11 is greater than or equal to negative 2. Hopefully it is greater than. So 9 minus 11 is negative 2. And that is, oops, equal to negative 2. That's good. And then that would be negative 1 is greater than or equal to negative 2. And negative 1 is greater than 2. If you look at the negatives, it's a bigger number. It's farther to the right, so it's a greater number. So that is true as well. So that's our checking. All right, so this second part, that's the addition property of inequality. The second part is going to be faster. We're going to go through this quickly. This is subtraction. The only difference is if you subtract something from both sides of an inequality, the result will be an equivalent inequality. So it's just subtracting something from both sides. So if you're starting with A is less than B, if you subtract the same thing, it could be a number, it could be just a variable that we're saying could be any number. But if it's the same thing from both sides, the A minus whatever that number is still going to be less than the B minus whatever number that is. So that means it's still equivalent. And an example to show that, we're going to just do two examples of solving and then graphing. So take your inequality, and just like solving a one-step equation with subtraction, you're going to subtract 6 from both sides, since that's the inverse operation here. That'll make the t all by itself greater than negative 10. And if I graph that, I've got negative 10 here. This would be going negative 9, negative 8, and so forth. This would be negative 11 over here. And when I graph that, it's going to be an open circle at negative 10. And it's going to be greater than negative 10, so we're going to the right. Okay, and the one I'd like you to solve on your own, see what you get for y. And then you're going to have to make sure the y is on the left side after you solve for it. So your one step, hopefully you'll figure out, is the inverse of addition, which is subtraction. Subtracting that from both sides. And you're left with y on that side. The symbol stays the same, and this will be negative 13. So then to flip it around, put the y in front and the negative 13 in the back, then you have to flip the symbol. So you flip it that way. Still opening up to the negative 13 then. So your solutions are anything less than or equal to negative 13. So you do your little number line here. We have negative 13 in there. Negative 12, negative 11, all the way down to 0. But this way would be negative 14. And this would be graphed at negative 13 with a closed circle. Since it has to be less than or equal to negative 13, it's going back to the left. Those are numbers smaller than it. So that is using the subtraction property of inequality, very similar to the addition property of inequality. And I'm going to leave you with one word problem that I want you to think about. It says the hard drive, and I actually I want you to write down in your notes what an equation would be for this, or an inequality. It says the hard drive on your computer has a maximum capacity of 120 gigabytes. You have used 85 gigabytes. You want to save some home videos onto your hard drive. What are the possible sizes of the home video collection you can save? So, I want you to, by class time next time, come up with an inequality for this situation. Alright? And the only other thing that you got to do, and you can do that in class next time if you want, but self-assess yourself about this section. Make sure you self-assess on your goal sheet. Otherwise, have a great rest of your day.